So I'm Indrajit, and I'll be talking about this work, which is collaboration with my colleagues Varun and Vinayaka at IBM Research India, and Roman, who is at IBM Research Watson. So kind of long title, so I'll first try and help you parse that. Over the last 5 years or so, analysis of social media has sort of moved on from analyzing trends and sentiments to more user-centric analysis. And one of the things that people have been looking at is trying to define or measure the extent of influence that individual users have on other users in the social media, right? And this is useful for various purposes, and one of them is basically to, they of course help marketing and law enforcement, but you can also try and understand the fundamental nature of social interactions between people from such analysis. And we'll see that in order to be useful, such analysis needs to be online, and it also needs to be topic-specific, right? So those account for most of the keywords in my title. I'll move on to the last one, which you anyway probably know. So the Wimbledon Championships is one of the oldest Grand Slam tennis tournaments, and it's one of the most followed annual sporting events in the world. So over the last few years, Wimbledon has developed a very big footprint on social media. So the organizers are well aware of this, and they wanted to get a perspective of this social, they wanted to understand the social perspective of the event, and they also wanted to present this social perspective to the millions of fans who follow this event online and on social media. So IBM has been the technology partner for Wimbledon over the last 25 years. And in 2014, IBM helped Wimbledon deploy what is called the Social Media Command Center at the Wimbledon Championships. Before I tell you what this analysis was specifically about, let me just tell you about the data that we got for analysis, right? So we only had the relevant tweets, no network information, and we'll also assume that it was non-spam. Of course, this was a difficult part of the analysis, but I'll not talk in more detail about how we got the relevant tweets for Wimbledon. So we also got a set of topics or aspects that were of interest to the organizers, and these were arranged in the form of a three-level tree, starting from the more general aspects at the top to more specific aspects. And I'll also assume for the purpose of this talk that these individual tweets or posts are annotated already with these aspects, so I can look at each set of tweets for a particular aspect independently of the others. Okay, so the other aspect of the data was the temporal nature of it. So we got the data in 1-hour batches during the course of the tournament, and I found this quite amazing when I first looked at the data, because looking at this, you can almost reconstruct or see the entire event, right? So this is actually where the event started. These were the semifinals. This was the men's singles final, right? So you can almost see when each of the main events happened, right? Just from the sizes of the batches, right? In terms of the number of users and the number of posts and the number of retweets and all of that, right? And one thing to point out is that the volume just keeps increasing over the sequence of the event, right? And so during the final hour of the men's singles final, right, we actually got more than 200,000 tweets from more than 120,000 unique users. Excuse me. And within each batch, we had these individual tweets which were sorted by time. And these tweets had several different meta tags. The ones most relevant from the perspective of influence analysis were these. So we knew who the user was who was posting the tweet. We knew the time of the posting. We knew the other users who were mentioned in the posts. We knew the number of followers of the user at the time of posting. And for tweets which were retweets, we had the meta information of the original tweet embedded within the information for that tweet. So for example, I knew who the original user was and what was the posting time of the original tweet. Right? So that was the data that we got for analysis. So what did we have to do on top of this data, right? So imagine for a minute that I already have a mechanism for defining the influence of an individual user based on a set of tweets, right? So supposing I have that, what would I have to do? So the first thing to note is that it's not very engaging to give one influence score for users at the end of the tournament, right? It's not even enough to do it at the end of the day. We want to be able to do it as the event is progressing, so we had to be able to do it every hour after one batch of tweets arrived, right? And we also had to do it for individual aspects, right? And not one generic set of influencers. So basically the idea was that the organizers wanted us to separate out, the strawberries and cream kind of experts from, the not too much spin on the forehand kind of experts, right? They're not the same. Okay, so we had to analyze the influence at the end of every batch. We had to analyze the influence for every specific aspect, but there was something else too. So for each time step T and for every aspect, we had to do two things, right? So we had to find out the all-time top influencers, right, based on all the tweets from the starting of the event until the current time. And we also had to find the recent top influencers from the data from the past interval of length delta, right? So to borrow an analogy from a different domain, right, the organizers wanted us to separate out the William Shakespeares from the J.K. Rowlings, right? I mean, they are both influential, but at very different timescales, right? Okay, so now coming to the actual influence score for individual users, right? So again, we had some basic requirements here, again, given by the organizers, and it also makes sense, right? So given the specific nature of influence of social media data, right, we could not simply borrow a notion of influence from some other domain, such as PageRank, right? Because social media has some very specific characteristics which make sense or provide evidence for influence, right? So, of course, we had to account for the network structure of the users, right? But there's activity, right? So there's volume of activity, and there's rate of activity, right? There's engagement with other users, and there's also the content, which of course tells us what is the topic of the tweet, but it also tells us what other users are mentioned within the body of the tweet, right? So we had to take all of this into account when defining the measure of influence for individual users. Secondly, what we call the usability requirements, right? The scores had to be simple to interpret and consume from the perspective of the users, right? They need to understand what a score of 59 means, right? Secondly, they also have to be easy to compute given the volume of data, right? If we can have a very complicated measure, but we wouldn't be able to update it efficiently after every batch of tweet arrives, right? Okay, so given these seemingly conflicting set of requirements, this is the overall, okay, step back. So these were the requirements. So there are several other things that are already available out there. Of course, Clout and Peer Index, Cred, Twitterlizer, and also several papers that talk about influence analysis specifically for Twitter. But this specific set of requirements that I talked about in the previous slide, there is no one score that does all of that. So what did we do to address these challenges? So we actually came up with, instead of a single score, we came up with an entire suite of scores, right? And on top of that, we had an aggregation mechanism that would basically aggregate all of these individual scores into one final score. This had several advantages, but the flip side was the aggregation. There are some tricky questions to be answered there. We figured out that just a linear weighted aggregation of the individual scores does not work, and so a rank aggregation works better for several reasons. I won't talk more about that here. You can read our paper if you're interested. So if you look at the suite of scores, some were pretty straightforward. We had the number of followers. We had the activity given by the number of tweets that individual users posted. We also had the engagement, which is the number of retweets and mentions for a particular user. All of them are relatively simple, but we'll see that not all of them work equally well. So we also had the centrality, which we defined as the page rank of the user within the follower graph for that specific topic or aspect. And then we had there's something wrong with the colors. This was supposed to be red. Anyway, there was one special score that we had. I just had to say it, right? This response rate, which looks at the rate of the tweets rather than the volume, right, is something that we wanted to take into account. And so I'll just talk about that for a few minutes. So we defined the response rate as the expected number of retweets that a user U can get if he posts one tweet on a particular topic within the next period of length delta, let's say 1 hour, right? So this is a predictive score. And the reason we are able to do this is that because we have a statistical model underneath for delays of retweets, right? So you might think that the total number of retweets divided by the total elapsed time gives you a reasonable estimate of the retweet rate. But this is not correct because it's reasonably well understood that the probability of a retweet does not stay flat over time. It actually decays, right? So one notion that we borrowed from the network influence community is this exponential distribution for modeling these delays, right, between a post and a retweet. So you can see the nature of delay of the exponential distribution. And importantly, this exponential distribution is specific for a pair of users and for a specific topic, right? And if we are given these distributions or the parameters of these distributions, then we can calculate this expected response rate in time that is linear in the number of followers of a particular user. But the issue is that these parameters are, of course, not known, right? So we'll have to estimate them from data, right? So in general, it is a computationally very difficult problem, but we figured out that when we restrict ourselves for retweets, essentially when no latent variables are there, all the variables are observed, there's actually a closed form solution for the maximum likelihood estimate for these parameters, right? And that is what we used for our work. Now, coming to the algorithms that we had to come up with to compute these influence scores from data. So again, the color will come up at some point, I'm guessing. Anyway, so what we wanted from the algorithms was that these algorithms ideally had to be online, right? What that means is that I should be able to update the scores at time t based on the scores at time t minus 1 and the new data at time t, right? Without having to go over all the previous data that I had. I simply cannot do that because of the scale. And of course, probably some summary statistics of the old data, right? So our observation is that all the scores that we had in our suite of scores have linear time online updates, which is very good, right? With one exception, PageRank does not have this. So there is some recent work on how to, have online updates for PageRank, but the algorithms are very complicated, and we did not actually use those. So we ended up computing PageRank from scratch, and this was feasible for a reason that I'll mention. Now, for response rate, this is actually a novel problem. So though our work is based on these maximum likelihood estimates of these pairwise parameters borrowed from the network inference community, the online nature of these updates had not been studied in that community yet. Now, in general, it's a difficult problem, but our observation is that it's not very difficult to see, but when you restrict yourselves to retweets, when who the sender and who the receiver are actually known or observed, you don't have any latent variables, then even for the online updates, you actually have linear time updates. Now, this is true for the exponential distribution, and this is also true for the Rayleigh and the power law distributions that are also used in the network inference community. Okay, so much about the algorithms. Let me now come to the actual deployment and what we learned from it. So this is a snapshot of the social command center that was deployed at Wimbledon. So you can see that this influencer panel was literally at the heart of it. And so when you clicked on that, you got to see who the current top influencers are. In this case, the top influencer happened to be Roger Federer. Well, not happened to be, he was a top influencer most of the times. And so you can see the individual scores for Federer here. So we did not really expose much more in the external interface, but I'll show you what we found from our analysis underneath. Because we continuously had to monitor this while the event was going on, we found quite a few bugs. We fixed them as well. But it was a very interesting experience. So we did some analysis of the individual scores, right? So recall that we had to find these influencers for many different aspects, right? And one thing we wanted to analyze is okay, was the top-ranked influencers across these aspects overlapping, or were they different, right? So I won't tell you the details. This is just trying to measure the rank correlation between the top 100 influencers for the different aspects that we had. And as you can see, so this is supposed to be a heat map, but it's basically flat, and all of the correlations are really bad. So what that tells you is that the influencers for the different aspects were very, very different. So it makes sense to do aspect-specific influence analysis. So the second observation is that we wanted to understand where the individual scores that we had in our suite redundant, or were all of them actually necessary, right? So we wanted to understand if we looked at the top influencers across these different scores, were they the same or were they different? Of course, you can see that compared to before, they are significantly more overlapping, and that makes sense because if all the influencers were different for two different scores, that would be a little troublesome, right? So they aren't, and the highest overlap is actually between response rate, which is the rate of retweets, and engagement, which is intuitively the volume of retweets and mentions. So of course, they are correlated, but the point is that the ranking based on rate and volume are different, right? And this is precisely what we wanted to see. So finally, I'll go into the user-specific scores, and this is the insight from the end of the tournament for the overall aspect, not the specific aspects. And there are several interesting things here. These are just the top 5 users according to the individual aspects. So the couple of scores in gray were the ones that did not work very well. As you can see, I mean, activity, followers, probably it makes sense that a user having a lot of followers does not necessarily mean that he's relevant for Wimbledon, right? Similarly, somebody who posts a lot is not necessarily influential, right? It's the response that matters. So, and also the generic cloud score, if we used it for analysis, we did not, we reported it here just for comparison. The generic cloud scores are, again, not relevant for the same reason. They are not relevant for these specific aspects for Wimbledon, right? Of course, you could use the aspect-specific scores there. So regarding these first 3 scores, they were the most interesting. So engagement, centrality, and response rate. So of course, you can see that there's quite a bit of overlap across these 3 columns, but they're not identical. So the point is, when you have these rankings, right, how do you figure out whether they're good, right? I mean, how do I figure out whether the response rate ranking was more accurate than the other ranking? So we, of course, don't have any gold standard on who the true influencers or the topmost influencers are for the individual aspects. So, some of them, we can probably expect them to be there. So Wimbledon is the official Twitter handle for Wimbledon, so it makes sense that it's out there at the top. Roger Federer, you'll probably expect them to be there. Djokovic, you would also expect him to be there. So there were some interesting names which were not there, right? And there are some interesting names which are there and you don't expect them to be there, right? So I've indicated a couple of them in red. So this was Liam Payne and Neil Horan. So for the uninitiated, of whom I'm one, so these are boy band members with millions of followers, but who are not really relevant for Wimbledon, right? So we were wondering what they were doing on this list. Okay, so again, I mean, just some notes about the evaluation. Of course, it's anecdotal, and of course, it's a precision-only evaluation. We don't really know who we are missing, right? So what we did is all through the tournament, we were trying to look at the actual people who came out on top, and there were 2 categories of surprising people, the non-tennis celebrities and the people who were not celebrities, right? So we were all through doing anecdotal evaluation of this category. And so under the hood, we sort of had these different, a panel where we could, do deeper drill downs to figure out what are the evidences for the different influence scores. And we were particularly interested in this Liam Payne phenomenon, right? So what happened is that he just appeared on the courts during one particular day of Wimbledon, and he posted one tweet, right? And it just went viral within a minute, right? So this shows the geographical spread of the retweets, right? 1 minute after he posted it, right? And of course, so our you remember that we had this score, which was the rate of retweets. So it was able to pick this up very, very quickly and correctly, right? Okay, so we also had some insights around the multiple timelines, but I think I'll just stop there and take questions with one point, that this notion of having fixed aspects was very troublesome, and we later realized that it's much more preferable to have flexibility there and to couple online topic discovery with influence analysis. I'll stop there.
Okay, and I think we have time for one quick question before lunch.
Being that there's a ban on usage on mobile phones within the Wimbledon site itself, when that ban was actually lifted, were you able to detect to see any increase in tweet rates around that time?
So this is interesting. So do you actually remember when it was lifted? So because we also deployed this for Wimbledon this year as well, right? And so I don't actually recall when this ban happened or it was lifted.
No, the ban stops at the end of play.
Okay.
So
Okay.
if with
So
the timing, you were able to see at the end of play when they could retweet between sessions,
sure.
whether the tweet rate went up.
So it's an interesting question, but we did not have geocodes on most of the tweets, so we were not able to figure out for all of them whether they were tweeting from the courts or from outside, right? So this is a mixture of all of them, and my feeling is that the people who are tweeting from the court are a very small percentage of the people who are tweeting overall. So there are some issues with trying to do that analysis simply because of the mismatch in the volumes, but it's an interesting question. I'll look at it.
Okay, and let's quickly thank the speaker.